Hi, my name is Tom. A few years ago I found a diet that worked well for myself and I probably lost 40 or 50 pounds. But one thing I noticed, I was weighing myself daily, and I noticed there's a lot of variation when you weigh yourself every day that you really can't explain. And this is even when you do things like weigh yourself the same time every day, same conditions. Maybe you weigh yourself in the morning, you're wearing the same type of sleepwear, you weigh yourself every day, and you seem to get a lot of variation that you can't explain. So one of the things, this can be frustrating, and some of the variability might be coming from your digital scale that you think is so great. So you might step on it, get off, weigh yourself again the next couple of minutes, and you get the exact same answer. Well, sometimes if you try this, maybe 15 minutes apart, you'll get a different answer. So the scales can trick you if they need to in software. If they get the same results a couple minutes apart, they can report the exact same answer. So you'll be led to believe that your scale is really repeatable. So it may or may not be, but regardless of the source of the variability, let's not worry about why that is. It could be hydration levels, whatever in your body. Let's figure out how to deal with it. So from a technical standpoint, this unexplained variation in the numbers or in your measured weight can be called noise. So what we can do is we can filter this, much like a water filter filters dirt out of the water. We can filter the noise out of the weight measurement you get every day, so you get a better idea of really how you're doing on your diet. So rather than get further into the technical details of this, let's look at some real data, and I can show you how to do this very easily. So it may look complicated to some of you right here, but it's really not that complicated. And I'll go through these calculations very slowly. Also keep in mind you don't need Excel or any other program to do this. You can do it by hand if you want. They're very simple. The hand calculator, and you could plot it or you can just record it, do anything you want with it. So what we're going to do is start with how the filtering equation looks, or how to compute a filtered weight value. So if you look up here at the top in row 1, it says today's filtered value equals the filter coefficient times today's measured value plus, in parentheses, 1 minus the filter coefficient times yesterday's filtered value. So if you kind of think about two of these terms, the filter coefficient and 1 minus the filter coefficient, those two quantities always have to equal 1. For example, if the filter coefficient is 0.3, then 1 minus 0.3 is 0.7. So 0.3 and 0.7 is 1. So basically you're kind of averaging or providing a contribution from the weight you measure on that day. So let's just take a look at it. Maybe it'll make more sense. Also note that the filter coefficients need to be at minimum 0 and maximum 1. So this is actually weight data for me. So on the first day you have really no filtered value. So the filtered values are just the measured values. So you just type them in. They're all 179. So on Monday I weighed myself, I was 179. So on Tuesday, if my weight was 177, maybe that was abnormally low. So the filtered values can shed some light on this. So let's just look at one. So the filtered value under what I call the more filtered value was 178.8. If you go up above it, the filter coefficient is 0.1. So what I did is you just say, as the equation states in the first line at the top, 0.1 times today's measured value, which was 177, plus 1 minus the filter coefficient, which is going to be 0.9, times yesterday's filtered value, which would be 179. So if you do that math, you get 178.8. Likewise, on Wednesday, if I weighed myself 177.2, what I would do is follow that same philosophy and say it's 0.1 times today's measured value, which is 177.2, plus this is going to be 1 minus 0.1, which is 0.9, times yesterday's filtered value, which was 178.8. So basically I just made a formula, and I'll click on one here, and you can see up in, well, you may not be able to see in the video, but it's a simple formula that just repeats this for me automatically. Now, one thing I want to show you, if we flip back to the graph, you can see the heavy filtered one is a very smooth line, and like I said, it doesn't follow the weight as quickly, but it's very smooth. So we can change these things. So take note of what these lines look like. Orange is my measured weight, which is very noisy and a lot of variation. The blue one's lightly filtered, red one's heavily filtered. So let's play with those numbers and see what happens. So under more filtering, I'm going to change this to 0.2, and maybe less filtering, I'll move that to 0.5. Let's go back and look at the graph now. So you can see now the heavily filtered, when I change the number a little bit, it's not quite as smooth. It follows the data a little bit better, so you don't have that lag. In fact, let's turn one of these off. Let's turn light filtering off and just play with it. So right now, if we go back, heavy filtering is 0.2, and it's a pretty smooth line. It's got a little variation. Let's change that to 0.3. You'll see more variation come in, but it'll follow the line a little quickly, less lag. So I changed that to 0.3. Go back and look at the graph. See, it's still pretty smooth. So you can play with this. You can look at your weight variation and decide what you want to use, but to me it would be a lot easier to try to figure out what's going on with my weight if I'm looking at this red line. It's not varying so much. So if I have one, in this area I have this wide weight swing all the way from 177 down to 173 in a few days. I really don't think I lost that much weight in a couple days. It's due to maybe being very hydrated one day and not so hydrated the next. So if I look at this red line, it's probably a better indication of what's going on with my true body weight when it comes to body mass. So I'll go back and we'll play with this a little bit more. I'll filter it maybe a little less. I'll change this to 0.4. Now on this one you see that it's getting less smooth, but it filters the measured value a little bit better. So it's a compromise. You can decide what to do with it, but I think it's a good method to analyze your weight. It seems to me that the 0.3, which we see on the screen right now, would be a very good value for you to use, but experiment as you like. Just fictitious example to kind of show you some more or illustrate some more things the filtering can do for you. So in this case, my measured weight, let's say it's actually 179, and pretty much getting 179 all the time, except for on one day I measure 184. So what you would see is when I have less filtering, the actual filtered value goes up to like 181.5. The heavily filtered value doesn't respond much to that one point and goes maybe 180.3 or 2. Then as my measured weight on the scale goes back to 179 forever, you can see how these values kind of converge back to where they were. The important thing is the filtered value doesn't react just to one data point. So we'll go ahead and I'll introduce one more. So we'll flip back to the data page. So you can see it was 179, 179. There's this one oddball point in here, 184, that caused the disturbance. And let's say I likewise the next day I get another noise or some explained variation. My real weight's 179. Let's call this 176. Put that in, and we'll see how that affects the filtered values. So if you look on the graph, my actual measured weight's this orange thing. It was 184, 176, and it goes back. You can see the red heavily filtered value doesn't respond much because this one point cannot contribute too much to the value, so it doesn't bring it down all the way, and the less filtered one doesn't either. So you can see how a little bit of disturbance or variation from day to day can kind of fool you if you're looking at your actual measured weight. You think like, well, God, I gained 5 pounds in one day and I lost like 8 the next, which is not possible. If you put the filtering in, you don't get those kind of results in the filtered value. So this is just a kind of a made-up example to show you the effects of the filtering. So this is going to conclude my video. If you have any questions, just contact me via the YouTube, and I'll see if I can get back with you, or if I get a bunch of questions, I'll try to respond to those generically. Thank you for watching.